All right, so let's get started. How's everybody doing? Had a good night's sleep in Barcelona? Yeah? Cool. I went to bed at 2 a.m. because something broke in this tutorial and I had to fix it. So I'm a little bit more stressed than usual, but I think it will go fine, all right? So we're here to talk about Cloud-Agnostic Serverless with Knative. And we've done this tutorial, I'm the founder of TriggerMesh, and we've done it in partnership with GitLab. So GitLab and TriggerMesh, we work actively together, and we've developed the integration of Knative inside GitLab, all right? So what we want to show in this tutorial is that you can use, if you have code in GitLab, specifically, but potentially other places, you can actually use Knative primitives, Knative API, to deploy serverless applications on any cloud. Any cloud, meaning basically anywhere where you're going to have a Kubernetes cluster on which you install Knative, right? It's a tutorial, so I have some slides. You should have gotten the URL, but we're going to try to do things hands-on, right? And that's why the folks from GitLab have given you some little pieces of paper with the login password to a test instance, right? So if you didn't get the credentials, raise your hand and we'll get you the credentials, right? Cool. So I'm Sebastien Goasguen. Helping me today is Cullen Taylor. Where's Cullen? Cullen. Oh, right there. Raise your hand, Cullen. Doesn't hear me. Okay, he actually wrote a lot of the tutorial. Chris, right here, raise your hand. Chris actually developed the integration of Knative inside GitLab. Priyanka was supposed to be with me here today from GitLab, but she was refused exit from the US. That's a good one. And I've been working on Kubernetes for quite a while, almost since the beginning. I developed with other people like Chris, things like Compose, K-Machine, Kubeless, one of the first serverless solution on top of Kubernetes, Cabin, and so on. And right now I've created TriggerMesh. I also do a bunch of things with O'Reilly. Maybe some of you have taken some of the O'Reilly courses that I give online. Okay, so just prereq for this tutorial, the little sign-in card. You have a username, workshop-user 123 through 200. You have the password. Everybody has the same password. Don't freak out, we'll scratch everything in 2 hours. And everybody can log into https gitlab tanuki.host, right? That's a GitLab instance. We're gonna connect to this GitLab instance. And from there, we are gonna try to deploy serverless applications or functions, all right? So that's the goal. Now, of course, you're welcome to do it. And if you just wanna, watch, please do so. Under the hood, there are things that we're going to use that hopefully are fairly transparent. And the goal of serverless is to make all the tooling and all the infrastructure transparent. But we do use, of course, Kubernetes cluster. There is a little bit of kube control. There is a Knative client called TM. And then there is the TriggerMesh cloud, where we actually pre-provision some accounts. So you're going to be able to deploy those functions on the TriggerMesh cloud, but without creating accounts, without putting your credit card, things like this, right? TriggerMesh Cloud, that's what I work on every day. Cloud.triggermesh.io. You're actually not going to see this, okay? You can technically log into it. You can also register an account, but you're not going to see it, okay? It's going to be transparent. Slides. Do you want the slides? 1, 2, 3, 4. 5. Okay. And the lab content, what we're going to try to do, so it's quite challenging in an hour and a half, an hour, 20 minutes to try to do, what we're going to try to do, okay? But we've thought, we would try to do 4 labs, okay? If everything works fine, it's going to be super smooth, okay? That's my hope. So gitlab.com, gitlab-workshops, serverless-workshop. Okay, this repo is actually cloned in the GitLab instance where you can log in. So you're going to log in onto those hosts. You got the card. When you log in, you're going to see a project or repository if you come from GitLab land, and you're going to actually see the content of those labs, right? We're going to try to do all the labs here right now, but of course, when you can go home, you can go back to those labs and try to do it on your own. Sounds good? I hope that's why you came here to do, hands-on stuff, right? So agenda, I'm going to try to keep it short. Introduction about serverless. This is not a presentation about, serverless per se. It's really tutorial and labs. And then we're going to try to do the labs. Hands-on, self-paced. If you go really fast, you can leave. We're going to do labs 1, 2, 3. Try to demo them live. And then hopefully a lot of you are going to be successful. Sounds good? Cool. Try to keep it short on a little introduction about serverless. So it's very challenging right now. At least that's my personal view. We have a bunch of IT landscapes. And as professionals, it's very difficult to navigate those landscapes. Even the CNCF landscape is becoming very challenging to navigate, right? So we're being bombarded with new tech every day, and Knative is no exception. You may have heard about Knative. You may have heard about serverless. You're being bombarded with those new paradigms. And the question is, what do you do with those? How can you adopt them? Are they going to help you solve issues and so on, right? So we're being bombarded with this. I tried to find a nice, picture to showcase bombardment, but apart from planes, didn't find anything. And then the CNCF landscape is quite overwhelming, right? And you see the growth here in the conference. It's been quite nuts the last 4 years. But this is very difficult. And the problem also is that even ourselves in our community, we tend to say, hey, it's the future. And there's this great blog, I don't know if you know it, from Circle CI that tells you, it goes basically through the cloud native technology, and it's one person who just wants to deploy a blog, and the other guy says, oh, well, it's easy, just take Docker and then, put a load balancer in front, and then you need a fleet of machine, and you need a container optimized operating system. And at the end of the day, the person who just wanted to deploy a website ends up having to deploy a whole slew of things, right? So really check out this blog. It's very funny, but it's actually quite true. And sometimes, we end up in this type of discussion. And the truth with that landscape is that it's very complicated. You end up create a cluster in the cloud, install a container runtime, install an orchestrator, install an app packager, then install 2 or 3 of those other systems using Helm on top of your orchestrator. Now deal with the networking, and of course install a service mesh, and then finally maybe you'll get to actually deploying your app, and it will be broken down in lots of microservices, right? If you do all of this, you're going to benefit from scale, you're going to benefit from automation, and velocity. That's the hope, right? But the truth is that this is actually super complicated. So, of course, when we have complication like this, the solution is to say, hey, we need new abstraction, we need a new paradigm. And we've been doing this, for a long time. And hopefully with those new abstractions, we get simplicity. So serverless, it's basically trying to abstract a lot of that complexity of managing the infrastructure so that hopefully you can focus on your application and deploying those applications, right? Main component of serverless, event-driven. So there are events flowing through the system, and you use those events to trigger little microservices or functions. It's using a lot of cloud provider services, maybe a storage system, machine learning system, you name it. And then the monetization aspect is that you only pay when you call your functions, right? So one of the big promise is that the cost is going to be reduced drastically. And then FAS, function as a service, is just the processing part of a larger serverless application. So you deploy functions, that's the FAS part, but then you need to manage all the events, right? That makes serverless, as a whole. And something like Knative is trying to make this extremely easy by giving you the API objects so that you can do this and not having to worry too much about auto-scaling and failovers and deployment scenarios and so on. Sounds good? Type of application coming from AWS, put a lot of pictures in storage bucket. In S3, automatically triggers thumbnail creation, triggers PDF creation if you're putting in Word documents, and then put them in another bucket. For example, file processing. Stream processing, you have lots of messages coming on an event stream, Kinesis or Kafka, you name it, triggers functions, stick something into a database, keep on going. ETL, you insert things into a database, DynamoDB, but could be also on-prem database, triggers a function, do some processing, and then archive the result, right? All these come straight out of AWS, okay? And at a high level, all these are application pipelines that are fairly simple, but the services that are being used for the storage, for the eventing, the database, and so on, all those are services that can scale and that are very resilient, right? So what has happened is that in terms of serverless, again, AWS is the leader, right? They are the leader with their AWS Lambda solution, right? What happens if you're not an AWS user, okay? What happens if you want to build that ETL pipeline, if you want to build that IoT application, in a very simple manner, but you want to make sure that it scales and things like this. But maybe you want to do it on Azure, maybe you want to do it on Google Cloud, maybe you want to do it on-prem. A lot of people think this is heresy to talk about serverless on-prem. But when you think about it as an application mindset or application architecture, you can totally think about it on-prem. So the challenge, is how do you do this? How do you build those apps without too much lock-in? And that's why we're using open source and we're at those conferences. Potentially with some services that are on-prem, right? And then limit the operational costs, limit the view of the infrastructure for your developers, your users, things like this. Right. Make sense? I'm rushing a bit, but we'll get there. So how do you do this? And I truly believe that Knative is the solution because Kubernetes has established itself as the leader in container orchestration. We've seen this over the last 4 or 5 years. So it makes total sense that if we have some type of serverless solution, it's going to be based on Kubernetes, right? Recently, Google announced Cloud Run, which is one of their new serverless offering, and it runs on top of their internal Borg. Maybe it runs on Kubernetes, I don't know. But most likely it runs on their internal Borg system, right? But if we want to do something like Cloud Run, but in a different cloud and maybe on-prem, it makes total sense to try to build that on top of your Kubernetes infrastructure. How can you do this? You do this with Knative. What is Knative? It's an extension of Kubernetes, extension of the Kubernetes API that gives you things like automatic scaling, better deployment strategies, traffic splitting, lots of benefits. You get them from the Knative abstractions, right? So you create a Knative API object, just one, and automatically you're gonna get a route for traffic splitting. You're gonna get an horizontal pod autoscaler. You're going to be able to do automated builds, and then you're going to be able to declare how you want events to flow and things like this, right? So that's the hope of this Kubernetes extension, is to give you all the primitives so that you can build those serverless pipelines. And who is familiar with CRDs, right? So custom resource definitions are an API object. CRD is an API object in Kubernetes that allows you to extend the Kubernetes API. Right. You can customize the Kubernetes API. So I talk about CRDs, quite a bit in different settings, but let's say that you want to create a new object called a database. You can actually write a manifest that declares what is a database object. You create this object, and suddenly Kubernetes is aware of a database, okay? Just from the API standpoint. Once you've extended the API, what you need to do is create controllers. Okay, they're also called operators. So that's why you hear things maybe KubeBuilder. Yesterday there was a workshop on KubeBuilder. There was a workshop from Red Hat on operator framework. So once you've extended the Kubernetes API with CRDs, you need to write a controller that's actually going to do things, right? You create a database, now a database object. Now what do? Well, you need to go somehow launch MySQL or launch Postgres somewhere, right? So you need to write the brain of that deals with your CRD. So when you install Knative, you get a bunch of CRDs. If you're a developer, you don't really need to know about this, but I'm giving this to you as if you're more of the operator persona so that you know what's happening a little bit under the hood, okay? Even though we want to abstract from it. So you install Knative, you get lots of CRDs, and with those CRDs, you're going to be able to build those serverless applications. Right? So we've extended Kubernetes. Questions? It's a high level, okay, because we only have an hour and a half. Yesterday, there was a full day on Knative. All right? Yeah. So just like any new paradigm, people come up with names, and then people argue about the name. So people argue that serverless is a really bad name, right? Because there are servers behind to run your process, right? But there is somebody in Europe, Patrick Debois, who is one of the instigators of the DevOps movement. He gave a talk a couple years ago, and instead of talking about serverless, he talked about serviceful. Which is that, he was actually developing applications, he's still developing applications cloud natively, so in the cloud, right? And his problem is that, he's using a lot of services. He's using, RDS, he's using S3, he's using Kinesis. So he's using a bunch of services. So his application is say, it's not serverless, it's serviceful, right? And to me, that's, it's very true, it resonates, because what you're trying to do when you build those pipelines, you're trying to write glue so that you can connect all those services. Right? So serviceful, it comes back, sometimes, but it's not gonna stick. People are gonna say serverless, but serviceful is better. Okay, lab 1. Shall we go? You ready? Shall we try? So what we're going to do in lab 1, we're going to connect to those GitLab instances. You have your little card. If you don't have the card, you can work with your neighbor. We're going to log into this GitLab instance, and we're just going to run a pipeline, a GitLab pipeline. And what that pipeline is going to do, we're going to look at it. That pipeline is actually going to talk to a Knative installation, which is the TriggerMesh in the TriggerMesh cloud. And inside that TriggerMesh cloud, it's going to use the Knative API to build a Python function and make it available, right? So if we're successful, you're going to run your pipelines, and then in the logs of the pipeline job, you're going to get a URL, and you're going to be able to hit that URL and get the, I think you get the time, something, okay? Does that, I'll show you, but does that make sense? All right. So let me log into one of those. Tani. So if you go to this host, GitLab tanuki.host, you log in with the creds that you got. You click on the workshop, the account has been seeded with existing code, and you can follow this and go through it, right? So the first one is lab 1, where we're doing something basic, which hopefully is going to work, which is to deploy a function, right? This function that's the problem with tutorials in conferences, is that you need a dedicated wireless. The function is just, a simple hello type application which is written in Python. So if you click here, you get basic Python script. And you notice that this function, so very simple Python, just one function endpoint returns, hello, the current time is, and prints the time. If you look at this function, it's exactly like what you can do in AWS Lambda. There is no HTTP server, there is no nothing. All of that comes in when you deploy the function via Knative. Okay, so that's just simple function. So what we're gonna do is just go to CI/CD pipelines. And then run the pipeline. Click Run Pipeline. Then I'm going to explain to you what's going to happen, what's happening when this pipeline is running, right? So Cullen assured me that 100 people on one GitLab instance was not going to be a problem, so we'll see. You confident? Who has a job that's running? It's ready? Okay. So the job is running. What is this job doing? You go into files, and this is, so that part is GitLab specific, okay? But when you run the pipeline, GitLab goes and looks at this gitlab-ci.yaml file. Can you see this in the back? Yeah? So GitLab goes through this, defines stages, so different basically steps, let's call them like this. And then you have deploy hello function. And you see that in this deploy hello function kind of stage, what's being used is an image, a Docker image. This Docker image comes from us, and that Docker image has a client that can talk to the Knative API. Okay? And then it does tm, there is some option here, config deploy -- wait. So tm deploy. So that's the basic command that actually deploys the function. So from GitLab, you're talking to a Knative install, okay? The config file contains the credentials, just like your Kubernetes kubeconfig. That's actually a Kubernetes kubeconfig. So you talk to the Kubernetes endpoint, and then deploy creates some Knative objects. What are those objects? Well, and my job failed. So the objects that get created, they come from this manifest serverless.yaml. Anybody here familiar with the serverless framework? All right. So it's not the serverless framework, but it's supposed to be fairly compatible, and it resembles the serverless framework. Okay. So what you have in this here is that you have the list of functions that you're deploying. So here you see an hello function. It tells you where the source of the function is, so lab1 hello. And then it tells you a runtime, which is what is going to basically package that function. And in the runtime, you end up with like an HTTP server so that you can call the function and so on. put a little description, and then some build arguments. Because this little function needs to somehow be injected, somewhere, and it ends up in a container, so that you can call that little bit of Python, right? So when you run the pipeline, it does tm deploy, and this tm deploy looks at this serverless.yaml, and from there, it creates Knative objects under the hood. So now I can look at my CI job and see what happened. And it looks like I got an error. Who got it running? Who got the time? 3, 4, 5-ish? Failed. Ah. Okay, that's no good. Let's retry. So technically, this is self-paced. So now that you're logged in on the instance, I'd like you to try to go through the labs. Okay, try to do lab 1, and I'm going to try to see what's going on here, and then we're going to try to do lab 2. Okay, let's take 10 minutes to do this. All right, try to do this. Yes. You got it? And then if you have questions, we got Chris over there in the back. Cullen is here. So if you have any questions, just raise your hand, and then one of us will try to get to you. Good. Looks like we got 79 of you. But are the functions running? Okay, somebody 98, you should be running. 58, you should be running. Yes? No? 41, 188. Are you running? Are you able to call your function? So the challenge of this workshop is that behind it, trying to make the infrastructure transparent, we have a cluster that's auto-scaling, right? And it's probably taking a little bit of time to auto-scale. So the experience of, very quick function, deployment is Good. Refresh. So here I'm logging in into the cloud that you're targeting, and I'm seeing all the pods, right? So while we do all of this, we end up with Kubernetes pods running that should be exposing your functions, right? So I see some of the pods, And when I look at this object, services, I'm going to explain what that is. If I click on this, I should get the time. I don't get the time. One or two. Who managed to hit his function or function? This could be my first epic fail in a tutorial. Yeah, just give me a couple minutes. If it doesn't work, I'm gonna move on. Wait a bit. No, I'm not waiting. I think it's a problem with the ingress, the network ingress. Okay, let's give it a little bit of time. Let's see if the system catches up somehow. So that's the basic thing, which obviously didn't work out exactly out of the box. What happened at the end is that Knative should have created what's called a Knative service. And a Knative service, it basically, under the hood, is going to create a Kubernetes deployment. You're going to get a pod. But you also get things like an autoscaler, and you get a route, which does, basically an equivalent to an ingress object, right? So in one API object, you encompass several things that gives you autoscaling, scale to zero, deployment strategies, and so on. To create those services, those Knative services, you have in the Knative serving namespace, you have a controller, so you have the brain that looks at those Knative CRDs. Knative exposes, as I said, services, routes, configuration, revision. So those are new objects, new construct that you have in your Kubernetes cluster. And as I said, they're higher level than the basic Kubernetes deployment. One thing that is interesting is that you have these revisions, which gives you immutable snapshot of your apps plus your config, right? So every time you make, potentially an update to your function, you make an update to the variable you give to that function, Knative is going to take a snapshot of both and create a revision object, right? Under the hood, what does a Knative service looks like? It looks like this. That's its most basic form. And at the beginning, it was a little bit confusing because what you see in this manifest is that you see a container. So there is a container called, GCR.io Knative samples hello world. So there is no concept of functions here, at least at the beginning. What you have is that you have a container, okay, that you have pre-built, but you deploy it with Knative service, and you get the auto-scaling, scale to zero, you get the routing, and so on. That's exactly what Google Cloud Run does, okay? And again, in the GitLab CI, when you do this TM deploy, it creates, nothing else than just this Knative service object and posts it on the endpoint. That service object is generated from the serverless.yaml manifest, which is more familiar to people who do lambdas. All right. So we did Go. It didn't work too well. Okay. Let me see if that started. Didn't start. Okay. So let me try to fall back on something then, because let's at least try to show something that works. If I go here in my cloud and I say I can specify one of those Docker images, and here I could say GCR.io Cloud Run hello. I give it a name. That's not good. There's wireless. Okay. So because of the wireless, it got delayed. You get an endpoint. Let's try to see if this is going to load. It doesn't load. I don't know if it's the network. Okay. Yeah? It worked for you? Okay. No. Okay, let me go through the rest of the lab, at least go, show you what they're supposed to do, and then looks like something is hosed totally badly here. The second lab that you can do on your own is more to do with serverless containers. The first one, you saw this little Python function, and under the hood it was supposed to get packaged and you would have gotten the time, right? If you do a serverless container, the idea here is that yes, if we expose container, it's not much of a function, but in the end, anything is going to be represented as a container. Container is a great artifact to deploy, right? So if you look, Knative has a system called the Knative build that allows you to actually build a Docker container inside a Kubernetes cluster, right? You can do build. I put the cat here just as a side note that Knative build actually gave rise to something called Tekton CD, yet another project in the landscape. And Tekton CD is now part of the Cloud Continuous Delivery Foundation, okay? So we pass on that. But because we have GitLab CI, we can actually build containers directly in GitLab, okay? So GitLab is very good at this. And the way GitLab does it is that it uses Kaneko, right? Have you heard about Kaneko? Okay. Kaneko is a great tool which allows you to build a Docker image without having a Docker daemon, right? And without having privileged containers that may have to mount, Docker socket and things like this. So if you use Kaneko, you can actually build a Docker image within another Docker container. That means that you can build a Docker image within a Kubernetes pod. So that's extremely, extremely powerful, right? GitLab does this, so you can modify your GitLab CI, and just in one of the stages, you can say, hey, actually build this container, right? Build this container, and then store that container in the GitLab container registry. Once that container is in the GitLab container registry, you can simply deploy that serverless container in the cloud of your choice that runs Knative, right? So we can try to walk through the lab. So clearly there is something wrong, but when I go back and that I cannot hit it, it may actually be good behavior, because if you don't hit your application, there is a scaling to 0, right? So if you don't hit it, scales to 0, no pods are serving that function. First time you hit it, that should trigger a wake up, and the deployment should scale up to 1, right? So while here it doesn't respond, it's not always a bad sign. It may actually, come up, a little bit later. But here, I think there is something more dramatic here about the situation. So we can go back anyway to workshop and look at lab 2. Feel it, 500. Refresh. Okay. So if you look at lab 2, there are lots of snapshots that tell you how to set it up, and you end up having to write a new GitLab CI file, which does this. Oh yeah, okay. There are 2 functions. So first you deploy the function. I just want to show you the Kaneko build here. So that step actually does the Kaneko build. Right, so you have an image, you see it's using Kaneko project executor. That's an image that contains the Kaneko binary. And then in the script, you see here /Kaneko/executor. This command is executing inside that Docker image, and that's going to build your app, right? What is it going to build? It's going to build this here, lab2 app Docker file. So there is actually a Docker file in the project. And that's a little bit controversial because some people say if you're truly serverless, you shouldn't have to expose, Docker file to users, right? This Docker file is pretty simple from Golang. It's going to copy the files, define an entry point, and so on. So when you run the pipeline, it's going to run this Canico build and Dockerize this app and store it in the GitLab container registry, right? The other function will still be running, and then when you execute the pipeline, they will actually talk to each other, right? So Cullen was telling me we'll leave the instances up so that you can actually, we're going to fix what's broken here, so that you can still do the lab, until Thursday or Friday. Right. The lab 3, I'm gonna try to do it for you. So here the hope was that you would have been able to deploy functions, transparently. Okay. But you can actually do this on your own with your own Kubernetes cluster, right? So that one, I'm gonna try to do it from scratch to show you what we mean, and that one may actually work if we get. I'm going to go to the hosted GitLab directly, and I'm going to create a new project. We're gonna try to do this from scratch. New project. KubeCon. Initialize. Right. So I'm creating a new project on the hosted GitLab. I have my new project, and let's say this is where I'm going to host my functions. Now I want to be able to deploy those functions, so I need to have an endpoint that I can target, right? So I'm going to go into here, operations serverless. So that's the integration that we did with Knative, and it tells me, hey, you need to install Knative. Right. I click, and of course, before I can install Knative, I need to have a Kubernetes cluster. So I add a Kubernetes cluster. This is the Kubernetes integration in GitLab, and I can add a cluster using GKE, Google Cloud, or I can bring my own by just putting in the credentials and the URL of my Kubernetes cluster. So I'm just going to do GKE here, sign in with Google. I'm going to call it KubeCon demo 2. One of my projects, sure, let's go in TriggerMesh. So this is my Google Cloud project, US Central 1, 3 nodes. Let's up the nodes a little bit to standard 4. It's RBAC enabled, create Kubernetes cluster. Right? And now when I go to my GKE interface, Kubernetes engine, clusters. I see that there's a kubedemo 2 cluster being created. It's not gonna take too long. Once this cluster is created, we'll actually deploy Knative into it directly from GitLab. Okay? And once we have Knative installed, we can start deploying functions onto that cluster. Yes. The default size of a GKE cluster is 3 nodes. How will it work for what? Yeah, so here, if you do this, you're definitely paying for the VM instances that your Kubernetes cluster is going to use, right? You won't pay for the functions because you're going to deploy functions and manage those functions, right? It is serverless in the sense that you have the operators of that cluster, internally at your company. That's what they're going to do. They're going to create the cluster. They're going to manage the Knative. But the developers, they're not going to see this. So it's a question of persona, right? But you still, if you do this, you still indeed have to, see the infrastructure and pay for the infrastructure. Somebody keep trying on lab 1 or lab 2? Okay, Kubernetes cluster now has been successfully created. To be able to install Knative, if you're familiar with Kubernetes and Helm, then you need to install Helm as a package manager. And that's what I mentioned at the beginning, right? Is that it's complicated. You need to install a cluster, you need to install an app packager. It gets complicated. That's where, serverless is supposed to shine. Is that technically you don't want to have to be able to do this, or your users should not have to do all of this. So here we installed Tiller, Helm, and then we come down here and now we install Knative, right? So I'm going to say what KubeCon.TriggerMesh.io. I give it a DNS domain that I want to use to be able to expose my function, and I install Knative. I'm going to open my Cloud DNS. The entire process here to do everything from scratch takes, roughly 15 minutes. Yeah, we have a problem with the network ingress because, see, under the hood, all the pods are being deployed properly, but the ingress is not giving us the traffic. Okay, so let's give it a little bit of time while it does the install. We get back to it. And the fourth lab that you can still do, we'll fix the ingress issue, is eventing. So we've talked about deploying functions, maybe having to do a build, which you can do on GitLab CI, and then deploy more of a serverless container. You can install everything from scratch. If you're a GitLab user, you can go to gitlab.com. If you are using GKE, you could do what I'm doing now, which is the full install from scratch. And then the fourth lab is actually to start dealing with events. Okay, that's actually the very interesting part. Deploying a function in itself, it's not super interesting, but starting to link events and services together, that's the exciting thing. So lab 4 is all about eventing. And in eventing, the idea is that you're going to consume event from whatever sources, and then map an event to a consumer. And you can do this in Knative with some new abstractions that they've developed. Channel and subscription are some of the objects that you have, and now there is also broker and trigger. So these are API objects, just like you have in Kubernetes deployment services and so on. These are extensions of the Kubernetes API that you can use in Knative. And with those, you're going to be able to say, hey, my events should go to this broker. And then, once they're on this broker, I'm going to be able to trigger this function using a particular event type and things like this, right? So you can filter your events and you can send them to, specific endpoints. So that gives you this, event to function mapping, right? Same thing then with serving. What you would see in your cluster, if you ever install it, from scratch and manage that cluster yourself, you'll see a Knative eventing namespace. You'll see a controller in that namespace. You'll see things like channel controllers, which are, under the hood, how messages are being managed or handled. So you see this this eventing controller. And then you have to define event sources. So a typical, I would say traditional type of event source is just a cron job, right? So a cron job, you define it and it regularly emits something, right? So here you have a cron job source. And you see that on schedule, it emits hello world. And in that object, you see that there is a sync being defined. So that particular way of defining the sync is making kind of a hard binding between the event source, this cron job, and the function, which here is a service, so a Knative service, right? So on schedule, it's going to send hello world to this event display service, right? Instead of pointing to a service as a sync, you can just send this to a channel or a broker, right? And then the events will be redirected to their endpoints, function endpoints, thanks to the trigger definitions, right? So you can do this in lab 4, and I'll show you a little bit how this looks like. Yes. Yes. Yeah. How did I call my domain? KubeCon. So here I'm going to say KubeCon. I'm adding the DNS record for the previous one. So I add a record for KubeCon and then a wildcard KubeCon. So now oh yeah, I didn't need to do save. Can I? So here, the cluster has been created. Knative has been installed. So now I can go to my files, and technically here I can now just go to the web IDE. Well, I shouldn't have. Well, okay, let me not go to the web IDE. I can just add a new file, which is GitLab CI.yaml. And here, let me go to another project and just steal something quick. Boom. Finally worked. Yeah, there's something off with the So here what we're going to do now is that, here we're going to say, okay, TM in the namespace, because you need to deploy in a specific Kubernetes namespace underneath. So TM-N, that's the namespace, kube namespace, service, deploy, demo, from image dcr cloud run hello. What did I do? Dash dash wait. Yeah, okay. And then should work. What? I switch. Deploy service. Right? So when you do this, GitLab is gonna go and just simply run this command tm deploy service, and here I'm deploying a container. This is typical Google Cloud Run type scenario, right? So let's see if I'm gonna get lucky. I need a little bit of luck. Give me some love. Okay, I've created the deploy, the GitLab CI, but now I need to actually trigger the pipeline. Oh, it's running. Okay, so now it's paused. Okay, so let's finish the, well, okay. Running? What? Runner? Disable runner? I need to install the runner. Where is it? Settings? Operations, Kubernetes. GitLab runner. Oh yeah, okay. I don't have a runner, so it doesn't know how to do the build. Okay, so that was another thing to install. So if we look just at the eventing, I just want to show you at least an example of the GitLab source here. So we've created an event source for GitLab. There is also in Knative an event source for GitHub. There is an event source for AWS SQS. We've created lots of other event sources for AWS services. But here you see a manifest that basically declares, hey, I want to listen to push events, merge request events, issues events on this project URL here. All right, so the system Knative is supposed to listen to events on that project, this type of events. And once it gets one of those events, it would send it to this sink, right, which is a function, right? So here you're declaring this event source, and you're doing that event to function mapping. Notice that there is a need of a secret because Knative is going to need to be able to talk to the GitLab API so that it can register webhooks, right? So in some ways, this is a way to automate the creation of GitLab webhooks. You create this object in your Kubernetes cluster, and automatically it's going to create a GitLab webhook. And then when you have an event in your repo, then the event is going to be received by that Knative event source and forwarded to your functions. Right? So this works very well when the functions show up. So you can do it in Lab 4. Okay, so here the GitLab runner has been installed. So let me go back to the CI to see if this is successful. Ooh. I told you I needed some love. Please give me some love. Right? And now if I go here, there's going to be some red, but don't panic. Right? Wow. Okay, it's running. So here you see the URL, demo KubeCon 12444, blah, blah, blah. That's my Kubernetes namespace that has been created by GitLab in the Kubernetes cluster. KubeCon TriggerMesh.io, that's the DNS domain that I registered in Cloud DNS. And this is the web app that's being served by this container, GCR IO Cloud Run Hello, right? That message here is normal. If you look at it, it's just like a way that Knative is configured. You know, it doesn't like the networking configuration. You could run that. This is the hello world of Google Cloud Run, okay? And here we just, you know, run it in GitLab, having provisioned a Kubernetes cluster and installed Knative from scratch. I should have just done that, you know. Right? And hopefully you get the idea from this GitLab CI here, right? That, you know, with this, that's how you can deploy your functions. Did somebody else got some love from one of the labs? You got some love? Oh, great. Oh, 3, 4. Oh, wow. 5. Oh, 6. Oh. What happened? Did we get? Okay. Yeah, it didn't like the load, or something was off with the ingress. Hopefully you will forgive us. So wrap up. Knative is an extension of the Kubernetes API, which gives you some primitives so that you can start building serverless applications that look like, you know, the pipelines that I've shown you from AWS. The serving, I haven't demoed the scale to 0, but what you'll get out of the box, even with that, you know, that Cloud Run application here that I just deployed, you'll get scale to 0, which means that if I refresh, not this one, if I refresh this one, if it has scale to 0, it's going to take a little bit of time to come back up. You see it's spinning. It's because since I didn't hit it, it scaled down to 0, and now what I'm seeing is cold start. So that's the cold start of restarting the container. Depending, you know, on the infra that you have, the cold start is, you know, bad or acceptable or whatever. Here it's, you know, a bit long, right? Measured cold start of Knative is roughly 2.5 seconds, right, in performance test, which, you know, is not really great right now, but it's going to get, it's going to be improved. Eventing allows you to trigger functions. So once you have everything set up, then you can start actually thinking about that application, and then, you know, declare that application through a set of event sources, triggers, and functions, right? So the idea definitely is that Knative gives you this portability, and that you can go serverless even on-prem, but, you know, in any cloud, using Kubernetes cluster and then deploying Knative. You know, clearly not great. It didn't work as expected here. We're gonna leave the instances up so that if some of you are highly motivated, you can still try to do the labs. They should work. We've gone through them. Here it looks like, you know, the load was not too good, or something went off with the ingress. But please, you know, try to do it. Reach out to us, you know, Twitter, whatever, LinkedIn, and if we can help you, you know, go through them and test everything, we'd love to answer your questions. Sebastien Goasguen right there, Chris right there. He's the one who actually did the Knative integration in GitLab, which actually worked. So, you know, that's the good thing, is that, you see, I demoed it from GitLab.com. You know, so this is live. You can use it. It's available. Any GitLab user can use this. So great job, Chris. Works well. All right. So thank you very much.